So I know everyone isn't seated yet, but because of the nature of tonight and also it's the last in our season, I've got a little bit more announcements than usual, so I want to just sort of get started so that you're not listening to me bump my gums and you can actually hear from the person you came to hear from. Again, I wanted to welcome you all. Most of you I know many of your faces because you come regularly, so it's been a great series. This is a great way to end the 2018-19 season. And I've got a few people that I'll get to welcoming, specifically who are here as special guests of either RICE or NASA. On your calendars, please note our next event will be September 12th, which is a very auspicious date for RICE. We're going to have a discussion and talk about the legacy of JFK and the Apollo program, continuing our celebration of Apollo 50. We're doing that in partnership with the John F. Kennedy Library Foundation and the University Space Research Association. So look out for, we'll put that together. It's probably going to be a talk and a panel discussion, so look out for that, please. And does anybody know what today's date is? Thank you. So this is the 58 years since Yuri Gagarin made his first flight. And I would like to invite welcome some special guests. We actually have 9 students from the Bauman Moscow State Technical University, if I got that in the right order. So we have 9 students and their chaperones. So we have 10 people from Moscow here today. Oh, we have 10 students plus 1. I'm getting apparently Russian for 1 more is the same as in English. So welcome. And this is part of an exchange program run out of the Baker Institute at Rice with George Abbey and Jason Lyons, who I think Jason's somewhere. Thanks, Jason. And there's also a reciprocal visit by US students to Moscow in the summer. So it's a really great program. It's been running for a number of years. We also have Rosemary Russo. I've forgotten where all the seating is now. So Rosemary is it CEO or president? What's your, for the Moon Foundation? The Moon Tree Foundation. And we had a couple of years ago, we planted a moon tree, and we didn't tell anybody because it was really small and we didn't want anyone to steal it. We wanted it to take root. And these moon trees, Rosemary's father, some of you might know the name, was Stu Russo, who was the pilot, or the what do they call the orbiter? The command module, thank you. So I've just lost my space credentials. So it's been a long day. So the command module, but he used to work in the Forestry Service, and what he did was he took a number of seeds from various trees that was some of his favorite trees, I guess, and he brought those back, and then they were planted, and we were lucky a couple of years ago for Rosemary and her foundation to come and donate, I don't know if it would be the child or the grandchild of those seeds. So we actually had a moon tree planted a couple of years ago, but we actually commemorated it today with Administrator Bridenstine and some guests. So great pleasure to be here with her husband Francisco too. So that's someone else we'd like to recognize. Do we have any visiting students, class of 2024? They're out partying. This is our days, so we're trying to encourage them to come to Rice, and I was hoping they'd be here because I think this would convince them. So the other thing I need to do is thank our sponsor, which of course is the Houston Spaceport. Arturo just flew in from Space Symposium. You all know Arturo. And I think because this is our last in the season, I'm assuming he's going to sponsor it next year, but you can talk to him about that. So the Houston Spaceport at Ellington Field got the license in June 2015, and there's been a lot of things really happening. You've probably seen some of the stuff in the news. We now have a Houston Aerospace Support Center in an old Boeing building down at Ellington Field that is now inhabited by Intuitive Machines, who are one of the companies that were selected to do a lunar lander. So we're actually doing lunar landers at the Houston Spaceport. We recently, you saw in the news that we opened a mission control enabled control tower so they can do aviation until we can get the horizontal launch capability from companies coming to Houston, and we'll be able to monitor them there. Pretty soon there'll be a groundbreaking on phase 1, which is going to include something I call the Design Solutions Center. We'll see what they call it, but basically working on space innovation and space technology. And there's also been a number of international agreements signed between the Houston Spaceport and various spaceports around the world. The one I'm proudest of is the one we did with Prestwick Airport/Spaceport in Ayrshire in Scotland. And I've just found a new Ayrshire friend from NASA today, Donna from, I guess, Associate. I can never remember all these titles. I've promised her she'll have a different title in 3 weeks because that's how it works. But so we're working that. So there's a lot going on at the spaceport, a lot to happen still. And so I think we're really reinvigorating how space is done in Houston and the kind of things that we're doing. And of course, we couldn't do all this without our friends from across the street down there in NASA. Okay, so that's me, bumped my gums and did my whole rice thing. What I want to do is introduce tonight's speaker. We're particularly excited about it, but one of the things I want to make sure you all are aware of, you all think he's here to talk to you, which he is gracious enough to do tonight, but the reason he's here is because of an invitation from students. So I think that's a great thing to acknowledge, is that the next generation, the generations to come in the space program are what matters, and they certainly matter to the current NASA administrator, perhaps more than most. And so we were lucky that there was time in the schedule to add an extra event, which is why Jim's here tonight. So I really want to thank you for that, and on behalf of our students. Again, I'd read things, but there's there's some really impressive stuff in this note, so I'll try and pick most of the highlights. So Jim Bridenstine was sworn in as NASA's 13th administrator. I'm sure that's a lucky number in this case. Almost exactly a year ago, and so we've seen lots of things change over the course of the last year, and I think a lot of it is in a positive gradient. So I think we're really excited about the future, and I think we're going to hear some of that tonight. And prior to that, he was elected in 2012 to represent Oklahoma's 1st Congressional District in the United States House of Representatives. And he served on the Armed Services Committee and, importantly for us, the Science, Space and Technology Committee. And that's where I think some of us in the space business first got to learn about Congressman Bridenstine. The passion for NASA and space exploration has been there. I'd like to think you got it at Rice, but we'll take credit for everything that we can. But really, that was always been there, even when he was a congressman before he took the current position. And so I think many of us are excited about what we've seen in the last year and what we're expecting to see in the coming years. Obviously, he's been working for the government for a long time, but initially in the U.S. Navy, flying the E-2C Hawkeye off the U.S. Abraham Lincoln aircraft carrier, where he flew combat missions in Iraq and Afghanistan, and he has more than 1,900 flight hours and 333 career-arrested landings. Those landings are the thing that scare me, so the fact you've done 333 of them is pretty good. And then he moved to the F-18 Hornet, and he flew at the Naval Strike and Air Warfare Center, which is, as you probably are aware from the movies, the Top Gun, the parent command to Top Gun. He transitioned to the U.S. Navy Reserve, and he went to Tulsa, Oklahoma, to be the executive director of the Air and Space Museum and Planetarium. Again, education and outreach is very important. He was promoted to the rank of lieutenant, or sorry, I'm British, to lieutenant commander in 2012 while flying missions in Central and South America in support of the war on drugs. And more recently, he's kept that activity with the Air National Guard in Oklahoma. And here's the big thing. He was a triple major, where? At Rice University. And he also earned an MBA from, I think, a place called Cornell, which is some little university somewhere else. So please join me in welcoming home NASA Administrator Jim Bridenstine. Use this, and then I'll run this.
I'll just use it. Can I use the handheld? David, hey, thank you.
What an honor.
Thank you. Thank you so much. Is this water for me, David?
Yes.
Can I use this? Okay. All right. Good. Well, what an amazing opportunity to come back to Rice University. I was reading kind of what I was gonna be doing while I was here, and they said that I would be speaking tonight at Keck Hall. Is that how you pronounce it? Keck Hall? And I remember thinking, well, they must have built a new building because there was no Keck Hall when I was at Rice University. And they're like, oh, it's over by Valhalla. And I was like, well, I know where Valhalla is, but where is Keck Hall? And then, of course, as I'm walking up, I realized that this is the chemistry lecture hall from the 1990s that now has a new name. And I will tell you, I remember, like yesterday, taking classes in this room from Professor Hutchison. And remember, like yesterday, coming in with my palms sweating for the midterms. As I was walking in, I can tell you that maybe there might be some of that remaining. Some of that heart rate starts going up. My palms start sweating. I was sitting right back here when I took my first chemistry test from Professor Hutchinson. And I remember it was stoichiometry, and there was somebody in the room that was there to intimidate the freshmen. And about 20 minutes in to the test, there was just this loud, shrieking scream, just, ah! And then they threw all their papers all over the room, and then they stormed out, and they said, I quit, and they ran out. And I was like, oh my gosh, where am I? When we went through matriculation here, you know, the president of the university said that they could fill every spot with somebody who was either a valedictorian or a salutatorian, that they could fill every spot with somebody who was a National Merit Scholar. And I remember thinking, where am I? Because I don't fit either of those categories. And then when I saw that, somebody run out, I was like, people are freaking out around here. What's going on? Well, the whole thing was set up. There wasn't a real... Nobody really freaked out. They were just trying to scare the freshmen. So, yeah. Anyway, I have great memories of this room, and it's good to be back at Rice University. I am here for the students. I was a student here myself, and I love this place. I really do, and I mean that sincerely. And I'll look forward to talking to the students more about that tomorrow. But what I'd like to do right now is just kind of share with you what we're doing now at NASA, some of the things that we're up against. Before doing that, I want to make sure I recognize here in the front row, we have a legend from NASA, George Abbey, who, of course, is at the Rice Baker Institute now, but he was the center director at the Johnson Space Center for many years. And I can tell you, any center I go to around the country, people know George Abbey, and they know his influence and the level of prestige that he brought to the agency, and, of course, now the level of prestige he brings to Rice University and the Baker Institute. So, George, thank you for being who you are and doing what you do in your wonderful career and everything you've done for the agency. Please. So, I just got back from the Space Symposium in Colorado Springs. Had the opportunity to talk to folks there about what we were up to at NASA. Couple of things that I think are important to note. I want to start by saying there was a big event that happened not too long ago. China landed for the first time in history on the far side of the moon. Raise your hand if you're in this room and you're familiar with that happening. It was a big day. It was a big day. And what's funny is I get invited as the NASA administrator to go talk to groups about how we're falling behind in space because China's on the far side of the moon. Know this, that was a big achievement. And by the way, I sent a tweet, congratulated them on it. Just a couple of months earlier, NASA was landing on the far side of Mars. And we were doing it for the 8th time in human history, and the United States of America is the only country that's ever been able to achieve that soft landing on the far side of Mars. At the same time, we had a robot, as a matter of fact, flying out into deep space that entered orbit around Bennu. The robot is called OSIRIS-REx, and OSIRIS-REx is characterizing Bennu right now, and will be making a low approach, eventually grabbing a piece of Bennu and bringing it back to Earth for the first time in human history, doing an asteroid return mission to Earth. And then, of course, at the same time, just maybe a month after that, we took that New Horizons robot. If you remember, back in 2014, it might have been 2015, it flew by Pluto took beautiful pictures of Pluto. Then we sent that robot well beyond Pluto into what's called the Kuiper Belt, or David, you'll probably correct me, Kuiper Belt, Kipper Belt, Kuiper Belt. There, Kuiper. I knew it. That's what I've been telling people, and everybody corrects me. Anyway, it's Dutch, and I had it right all along. But here's the thing. This is the important thing. We need to standardize some of this terminology around NASA, because it doesn't matter how I pronounce it. Somebody's going to tell me it was wrong and how to really pronounce it. But anyway, that's good. Kipper is a breakfast fish in Scotland, he says. So he knows how to pronounce it. All right, so the Kuiper Belt. So we flew by this asteroid in the Kuiper Belt. And it's called Ultima Thule. And this asteroid is what we call a contact binary. So it's two asteroids that are connected and have been connected now for I don't know how many billions of years, but nobody really knew what we were going to see. And by the way, this asteroid that we just took a picture of, and it's absolutely beautiful, and great science is coming back from it every day. This was 4 billion miles from Earth. 4 billion miles from Earth. What an amazing capability. And of course, we had a couple of probes that were launched back in the 70s that actually left the solar system altogether and are now, no kidding, in interstellar space, which has never happened before either. And then just a few short months after that, remember, while all of this is going on, your little agency called NASA, and it belongs to you, make no mistake, your little agency called NASA has been operating a space station in low Earth orbit for now 20 years, and we've had humans living and working on that space station for 18 years. In other words, the freshmen that are coming to Rice University have never lived a day when we didn't have humans living and working in space. That is an amazing achievement by this little agency we call NASA. And while all of this was going on, we were launching for the first time what we call the Crew Dragon to the International Space Station, commercial crew. We've already demonstrated very successfully commercial resupply of the International Space Station. Now we're doing, very soon, commercial crew to the International Space Station with the goal to eventually commercialize low Earth orbit in its entirety. I know somebody is here who is now a graduate of Rice, or who will soon be a graduate of Rice University, who is taking a job with Axiom, and they're going to be commercializing low Earth orbit. In other words, commercial habitation so that humans can go live and work in space commercially. Again, all of this being developed by NASA, the goal being so that we, instead of being the landlord, we want to be a tenant. NASA will always be in low Earth orbit, but we just want to be a customer of low Earth. Why do we want to do that? So anyway, I'm setting the stage that if anybody is suggesting to you that NASA is falling behind, know this: we are not. We are ahead. We're continuing to move ahead, but here's what's new. This is not just about how great NASA is. We're doing it with our international partners. Remember, I mentioned that we landed on the far side of Mars back in November of last year. When we landed on the far side of Mars, we did it with partners from France and from Germany and even from Poland. This was an international collaboration. With the International Space Station, we have 15 nations owning and operating the International Space Station right now. That's an amazing achievement. Talk about a diplomatic achievement. It's a treaty. The International Space Station is a series of international treaties. We've had 103 different countries doing experiments on the International Space Station, with 238 astronauts at this point having lived and worked on the International Space Station. And I don't know from how many different countries, a lot, just know that. So anyway, all these things are going on and happening. We're not falling behind, but it's not a race anymore. The 1960s are over. This is about international collaboration. It's about American leadership. We're the only nation on the face of the planet that can pull all of this off and bring everybody together to achieve these monumental achievements. But what we're doing now is absolutely stunning. So let's talk about what the goal now is. The goal now is to get to the moon. The president has issued what we call Space Policy Directive 1. And in that Space Policy Directive, he says, go to the moon, but he says to do it in a way that's never been done before. Go sustainably. In other words, this time when you go to the moon, stay. So the question is, how do we make that work? Well, we have to have reusability. We have to drive down the cost. We have to increase the access. We've seen what happens when we reuse rockets. You guys remember, I just talked about this SpaceX launch that ultimately put the Crew Dragon attached to the International Space Station. A lot of people probably saw just, I don't remember if it was yesterday or the day before, yesterday, the Falcon Heavy that brought all 3 boosters back to Earth for reuse. It's driving down the cost. It's increasing the access to space. Well, we don't need just launch to be reusable. We need tugs that go from Earth orbit to lunar orbit to be reusable. We have Miss Russo in the audience. Her father, Stuart Russo, from Claremore, Oklahoma, just outside of Tulsa. Stuart Russo was the pilot of that command module in orbit around the moon while astronauts were on the surface. We need a reusable command module. When I say reusable, what do I mean? I mean a permanent command module in orbit around the moon all the time. We call it Gateway. 15 years. It's going to have a lifespan of 15 years. You think back to Apollo, that entire Saturn stack, as awesome as it was very expensive, and not a single piece of it came back to be reused. Even the astronauts, when they came home, that command module, the little gumdrop at the very top, it ends up in a museum, which is beautiful, and we all love it, and we share our history there. But ultimately, we want to reuse as much of the architecture as possible. When we reuse it, we drop down the cost, we increase the access, and that's ultimately what makes it sustainable. But we need that reusable command and service module in orbit around the moon permanently. We need reusable landers that can go back and forth to the surface of the moon and then back to that command module. That's the architecture that we're attempting to build. But beyond just reusable, that command and service module that's going to be in orbit around the moon permanently, it's going to have solar electric propulsion. 50 kilowatts of solar electric propulsion. What does that mean? That means it's going to be maneuverable. It's not going to just be in that near rectilinear halo orbit that we call it. You think of it an equatorial orbit. It's going to have propulsion, so it can go to the L1 point and the L2 point. In other words, we're going to have more access to more parts of the moon than ever before. You go back to 1969, we landed on the moon. We did 6 missions. We had 12 people walking on the surface of the moon. By the way, you'd be surprised how many people in this country believe that it was all faked. I hear that as the NASA administrator. So which one of the 6 missions was faked? Which one of the 12 astronauts? Which one of the 400,000 people that were involved in this operation was able to keep that secret? I mean, it's crazy talk. But at the end of the day, when we talk about these particular missions, from 1969 to 1970, by the way, the daughter of one of those is here, by the way. Good way to keep a secret. Right. So when we think about this, from 1969 to 1972, with all of these lunar missions, here's the thing to remember. We believed that the moon was bone dry. I should say this. Most people believed that the moon was bone dry. There were people who hypothesized that there could be water there, but we believe the moon was bone dry. 2008, India made a discovery. 2009, NASA makes a discovery. Hundreds of millions of tons of water ice at the poles of the moon. Hundreds of millions of tons. What does that mean? Well, that's life support. It's air to breathe. It's water to drink. It's hydrogen and oxygen. You crack it into its component parts, put it into a cryogenic form, and it is, no kidding, it's rocket fuel on the surface of the moon in hundreds of millions of tons. So all of that colludes to say, wow, that's an amazing discovery that for 39 years we had no idea existed. What else on the moon do we not know? That's why we need a reusable command and service module. That's why we need the Gateway, not just to be there for 15 years, but we need it to have propulsion so it can go to more parts of the moon and get those landers to more parts of the moon than ever before. So when we talk about those landers, we want more access to more parts of the moon robotically, with landers, with rovers, and with humans. That's the architecture that we're developing. So the president said in Space Policy Directive 1, he said, go to the moon. He said, go sustainably. Means we got to build reusability into the architecture. Part of sustainability means use commercial. That's written in Space Policy Directive 1. Go with your commercial partners. Why is commercial so important here? Well, there's different ways of doing contracting that can accelerate the process, that can drop down the cost, and then eventually NASA could become one customer of many customers, which again drops down the cost. So he says, go with commercial partners. Then he says, go with international partners. That's a key piece here. If we want this to be sustainable, we can't go alone. We need to go with our international partners. And he says, this is a brand new space policy directive, utilize the resources of the moon. Hundreds of millions of tons of water ice. Guess what? We're going to use it. We've got to figure out how to use it. And then he says, we're going to take all of what we learn and we're going to go to Mars. So the technologies and the capabilities that we're developing, yes, we're developing for the moon, but we want all of these different capabilities and technologies to feed forward to Mars. So if we're building something that is dead end, we got to rethink it. Is there a way we can use this in the Martian environment? Why is that important? The moon, friends, is a proving ground. It is the best place to learn how to live and work on another world. It's a proving ground. So here's what we know about the moon. It's always with the Earth. It never leaves us. And it's a 3-day journey home. And if something goes wrong, people can make it home. Stuart Russo was on Apollo 14. It was a return to flight after Apollo 13, which ended up being a great success. But Apollo 13 demonstrated that if something goes wrong between here and the moon, you can come home. The challenge with Mars is that the Earth and Mars are on the same side of the sun only once every 26 months. So when you go to Mars, you're going, and you're going to be there for a couple of years. Again, we have to live and we have to learn how to live and work on another world. The moon is that other world, so that eventually we can go to Mars. So we're going to go to the moon. We're going to go sustainably. We're going to go with commercial partners, international partners. We're going to utilize the resources of the moon. We're going to learn how to live and work on another world. We're going to retire risk, prove capability, prove technology. As much as possible, develop things that we can replicate for an eventual journey to Mars. That's Space Policy Directive 1. The president gave me that about a year ago. Here we go. Just a little task. But we're going to get it done. NASA can do this. So we put together a budget request. The budget request said that we're going to have our first humans on the moon in 2028. Friends, that's not going to work. The president and the vice president saw that and they said, no, 2028 is too long. We need to go faster. We want to get it done in the next 5 years. And then they looked at me and they said, make that happen. I don't know if any of you saw the National Space Council that happened about a month ago. But the vice president said very clearly, by direction of the president, we're going to go in the next 5 years. He said, the next man and the first woman on the moon will be Americans. And we're going to make that happen in the next 5 years. Did I hear there? There you go. So this is what we're up against now. So the question is, how do we go from 2028 to 2024? And that's what we've been working on at NASA. We had the plan to have our first humans there in 2028. Now what we're doing, we're starting we're breaking it into 2 phases. The first phase is getting to the moon and getting there quickly. We want that first woman on the moon in 2024. The second phase is sustainability. How do we build into the architecture all of the things that are necessary to stay for the long term? I want to be clear, when I say sustainability, I don't mean a permanent habitation on the surface of the moon. When I say sustainability, what I'm talking about is the ability to have access anytime, anywhere on the surface of the moon with landers, robots, rovers, and humans, eventually humans by 2024. So that's the objective behind the President's Space Policy Directive 1. So we talk about what we need to do. The Space Launch System, really big rocket, capable of carrying the Orion crew capsule and the European Service Module. I know there's people here from Lockheed Martin that are working on the Orion crew capsule. And of course, people here from NASA that do the same thing. So we need to get that space launch system, that massive rocket that can take our crew to the moon. We need to get that complete. Our goal is to have that done and tested around the moon. The Orion crew capsule with the European service module and the SLS rocket, we want that tested by the end of 2020. When I say tested, I mean Orion having flown around the moon by 2020 uncrewed. Then we need to move quickly to what we call EM2, Exploration Mission 2, where we actually send humans on a trip around the moon, testing out all of the life support systems in Earth orbit at first, and then doing a free return trajectory around the moon. Then we have EM3. That's going to be when our crews launch on an SLS to the moon, and this time they dock with an already built gateway in orbit around the moon. When I say the gateway, that's that reusable command and service module that we need to have in orbit in 2024. So how do we get from here to there? We've got 3 SLS rockets between now and then, maybe a 4th, depending on how fast we can accelerate. 3 SLS rockets. In order to build that reusable command and service module in orbit around the moon by 2024, we need to focus on the first elements, a power and propulsion element and a habitation module. We get those 2 elements built, guess what? Those are going to have to launch commercially. They're going to have to launch on rockets that already exist because we don't have the throughput necessary for the SLS. So we have rockets, commercial rockets, that are going to launch components of the gateway to put that in orbit around the moon by 2024. Then when we launch our crew on EM3 to that gateway, we will have aggregated at the moon the power and propulsion element and the habitation module. That was the original plan. Now the president says, we want to be there in 2024. Once you're there, the question is, how do you get to the surface? We need a transfer vehicle that can get from that near rectilinear halo orbit around the moon down to low lunar orbit. Then we need a descent module, and we need an ascent module. The gateway is our ability to accelerate. We can aggregate those elements at the gateway by 2024. The difference between then and now is, if we're going to land there in 2024, which we will do for the NASA people in the room, so if we're going to land there in 2024, we're going to need to take some of that budget from 25, 26, 27, and 28. We need to move it forward. And we recently put out a synopsis for a broad agency announcement on lunar landings. We did it for a transfer vehicle to get to low lunar orbit. We did it for a descent module maybe a month or 2 ago. And now, just last week, actually, what week are we in? Just this week, we did it for the ascent module, which is how our astronauts will get off of the moon and get back to Gateway for a ride home on Orion. Friends, this can be done. We can have humans on the moon in 2024. And we can also, at the same time, be building sustainability into the architecture. So part of what we need to do right now is figure out how we're going to fund it. So right now, what we're doing at NASA is we're putting together a modification of the budget request so that we can have Congress fund what we're trying to achieve. I want to be really clear here. We cannot achieve what we're trying to achieve in a partisan way. It has to be an all-of-America approach. It has to be bipartisan. We all have to get together and say that this needs to be done. So in order to achieve bipartisanship, a couple of things. Some people have said, well, are you going to take the money from the International Space Station? I know where I am. I'm in Houston. The answer is no. We have no intent to take the money from the International Space Station. There you go. So how do we achieve this then? Do you plan to take the money from the Science Mission Directorate? The Heliophysics Department? David, no, we're not going to do that. Are we going to take it from the Earth Science Division? Are we going to take it from astrophysics, planetary science? The answer is no. Why? Because this has been tried before in American history and it doesn't work. Some of you are familiar with the Space Exploration Initiative, which goes back to the 1990s, which was a return to the moon. Some of you are familiar with the Vision for Space Exploration, which goes back to the 2000s, which it ultimately didn't work. Why? Because when when you cannibalize one part of NASA to feed another part of NASA, it becomes political, it becomes partisan. In some cases, it becomes partisan. In other cases, it just becomes parochial. What part of the country are you in, and who are your constituents that are going to be damaged by this plan? And then it becomes bipartisan opposition. We have to avoid all of that. And so what we're working on right now is figuring out how do we fund this without cannibalizing other parts of the agency. And we're working to come up with a plan to make that happen. We're going to work with the Office of Management and Budget inside the administration. We're going to work with the National Space Council inside the administration, which, by the way, is a great success for our country. There are some people in the room that are familiar with the National Space Council that goes back to the 1980s. I should say I guess it ended in 1992. But it goes back to the 80s, and then before that it was going on in the 1960s. The president said, we're going to create a National Space Council. We're going to make the vice president the chairman of it, and we're going to put cabinet secretaries and heads of agency that deal with space on that council. And we've been meeting. In fact, this recent direction to land on the moon in 5 years came from the most recent meeting. And it's got the Secretary of State, the Secretary of Defense, the Director of National Intelligence, of course me, the NASA Administrator. It's got all the FAA, which has the Office of Commercial Space Transportation. It has the Office of, it has the Commerce Department, the Secretary of Commerce. So all of these agencies that deal with and touch space are all involved in the National Space Council, chaired by the Vice President. Friends, that is a brilliant move. And if we're going to achieve what we need to achieve, that's the level of support that we need as an agency that we haven't had in, quite frankly, a long time. But now we've got it. And now we have a new direction to go to the moon in 2024 and to, no kidding, make it sustainable by 2028. Speed equals sustainability. I think that's another important point. Each of those previous efforts, the Space Exploration Initiative, the Vision for Space Exploration, they all got cannibalized because they took too long. And I don't know how many times I've heard people ask me as the NASA minister, is this Lucy in the football again? How many times have I heard that? No, this is not Lucy in the football, and the way to mitigate some of the political risk is to go sufficiently fast as to not be cast to and fro by one political election or the next. And I think so all that is a very positive direction. Something else that's important to note. I talked earlier about the commercialization of low Earth orbit. That's an important component to this. NASA needs to be in low Earth orbit. We have to be in low Earth orbit. The International Space Station is our tool to learn how to commercialize low Earth orbit, and we're working on that every day. Commercial resupply has been successful. Commercial crew has been successful. We now need commercial habitation in low Earth orbit. And if we can commercialize, then NASA becomes one customer of many customers, driving down our cost in low Earth orbit. But we also want numerous providers that are competing on cost and innovation, driving down our cost and increasing access at the same time. So we need those market forces as well. And when that happens, then we can use our resources that the American taxpayer gives to us. We can use those resources for activities for which there is not yet a commercial marketplace, namely the moon and then Mars. So I think all of that is on the agenda for what we're trying to achieve. So there's no shortage of things that we're trying to do right now. The challenge is big. The risk is there. When I say risk, I'm not talking about programmatic risk. I'm not talking about technical risk. The first thing we have to retire is the political risk. We have to get this thing funded. There's opportunities to do that, but it has to be done in a bipartisan way that doesn't end up in a parochial dispute. And then once we retire the political risk, then we have to go after the programmatic and the technical risk. And all of that is going to exist after we get the political risk retired. But here's the thing, because the people in this room, some of you know the people in this room that are involved in these programs and projects, it's all possible. We can do this. Absolutely, we can do this. All right, I'm going to stop talking for a few minutes, and we'll just open it up to questions, if that's okay, David. And do you want to select the questioners, or? Thank you.
Well, I'm going to go try and find, I think we have another handheld, so I'm
Okay.
going to try and find that while you're answering the first question.
Okay.
So I'm going to try and find another handheld microphone because you know what I've been like the last few weeks going around with this. So I can take a question, we can repeat it here, and then hopefully by the time the answer comes, I'll have a separate microphone. So let's see the first hand in the middle here.
Thank you.
I've heard early reports of the results of the Kelly-Quinn study, Scott Clark, and the results seem to indicate re-indicate the danger of long-term flight. Are you seeing the necessity to accelerate the program to get a constant propulsion practice for
Yes. Absolutely. So his question is about the twin studies that the Kelly brothers had, where we had one twin on the International Space Station for almost a year, another twin on the ground, and now we're seeing the physiological effects from that to include changes in DNA and other things. And yes, here's what we know. We know that space travel is hazardous for the human physiology. A couple of things that everybody is aware of, and we're learning more and more every day. An astronaut will lose 1 to 3% of his or her bone mass every month when they're in a microgravity environment. The immune system gets weakened in a microgravity environment, significantly weakened, which is why it's so important that our astronauts are as healthy as we can possibly get them to be. That's why they end up being quarantined before they launch, and we got to make sure that they're as healthy as they can possibly be before we launch them. We also know that there are effects in the cranium. So when you're in a microgravity environment, you don't have the blood being pulled to your feet. The blood floats up, and it creates not just blood, but other fluids, creates a lot of pressure in the cranium, and that ultimately results in challenges with eyesight and nerves and other things that are problematic. So we have learned these things on the International Space Station. And of course, the effects of radiation are challenging as well. So the question was, and I think it's the right direction, are we planning to figure out how to accelerate the journey? You know, when we talk about going to Mars, we're talking about flying there for 7 to 9 months, which is exposure to a lot of radiation for a long period of time. So there's a couple of things we can do. We have to figure out how do we protect our astronauts. And of course, we're going to have experiments to learn some more about how to protect our astronauts when we do EM1 SLS launch, which is going to take Orion around the moon. We're going to learn about how to protect our astronauts with a vest. We've got a partner with the state of Israel and a partner with Germany on those activities, which is going to be very revealing, and we need to learn there. It's also true that the gentleman said, correctly identified, we need to get there faster. Instead of 7 to 9 months, if we can get there in 2 or 3 months, it reduces the dose of radiation. So how do we get there in 2 to 3 months? Nuclear thermal propulsion. If you listen to the Vice President's speech the other day at the National Space Council, he was very clear that nuclear thermal propulsion is something we as a nation ought to be developing in order to get to Mars faster. Did I hear some claps on that? You can feel free. So those are things that are all in the mix. Now, nuclear thermal is the beginning. The next is nuclear electric. I mean, that's the holy grail, how we're going to get from one side of the solar system to the other. So when we think about propulsion, what are you doing? This goes back to my days here at Rice University in this lecture hall. Maybe you remember the equation PV equals nRT. I only remember that because I'm sitting in this room. If I wasn't in this room, I wouldn't have just recalled that. But PV equals, so what we're doing here is we're taking a mass and we're accelerating it out of the back of a rocket. That's what we're doing. So there's two things that you can do to go faster. One, you can make the mass more that you're accelerating, or you can accelerate it faster. Well, even with nuclear thermal, and this is the challenge, even with nuclear thermal, there's a limitation on the amount of speed that you can get. Why is that? Because we have a challenge with material science. It ends up being so hot that you're still limited in your speed. But if you can take, say, a subatomic particle that has a charge, and you can accelerate that at a percentage of the speed of light out the back of your rocket, Now you're talking about being able to accelerate really, really fast. And because it's a subatomic particle with a charge, you can actually control it. You can control it in a way with magnets where it doesn't come in contact with the materials, and the materials won't be damaged themselves. Now, that's the next step. So nuclear thermal is next, nuclear electric is after that, and all of these capabilities are on the horizon. In fact, NASA's investing in each one of them even right now today, and we need to continue to invest in them. But the bottom line is you're absolutely right. Here's the other thing that's important when you talk about the twin study and radiation. People talk about, well, if you go to the moon and you have people living and working on the moon, the radiation is going to be really high. It's true, the radiation is high on the moon. The other thing that's true is you can get under the surface of the moon. You can get into those lava tubes without even having to dig. You just walk in there. I say that, I don't know. Nobody really knows, but we're going to find out. So you get under the surface of the moon, and then it reduces, you're protected by the surface of the moon. The other thing that's important to think about is that when you're on the moon, even if you're on the surface of the moon, you're getting 50% of the dose of radiation that you would get if you were not on the surface of the moon. Why? Because everything below you is blocked. So your dose of radiation when you're on a planetary body is cut in half, and if you can get under the surface, you're even safer. It's another reason why we need to get to the surface of the moon. Our goal here is not to be permanently in orbit around the moon. People have said, oh, well, we just need to build this spaceship in orbit around the moon, and then eventually we'll take that to Mars. Well, no, we need to learn how to, we call it in situ resource utilization. How do we use the resources of the moon to live and work for a longer period of time? How do we get to the surface of the moon and learn how the physiology is affected, learn how to protect the human condition? So here's the other thing that's important. We think about Mars, another great thing that we now know. Just since I've been the NASA administrator, we've discovered that there's liquid water 12 kilometers under the surface of Mars. Liquid water, 12 kilometers, that's just in the last year we've learned this. What do we know about water on Earth? Everywhere there's liquid water, there's life. I'm not saying there's life on Mars. I don't know, but neither do you. But we ought to find out. So these are all, I think, important things that we need to do for the agency and for our country. And by the way, if we discovered life on another world, I have a feeling that there'd be a lot more interest in going further than we already have gone. The other thing is, other things that we now know about Mars because of the Mars Curiosity rover, and before that, Spirit and Opportunity. Talk about great investments. These were robots on Mars that were expected to last for 90 days and maybe go 100 meters. And instead, these robots, one lasted 10 years, the other lasted almost 15 years, and able to travel something like 23 miles. Don't quote me on that if you're in the media, I don't know. But it was a lot. That's the thing when you run NASA, every number you say gets corrected by 100 different people all over the world. I just get used to it. So, and I know all of you in the room are trying to correct me right now. You're like, do I correct him? So anyway, when you think about Spirit and Opportunity and Curiosity, and you think about what we're doing right now with InSight and Phoenix before InSight as far as landers go, all these activities on Mars, here's what we know. In the last year, we have learned that the methane cycles on Mars are perfectly commensurate with the seasons of Mars. That doesn't guarantee there's life, but the probability just went up. Could be geological, who knows? We have also learned that there are complex organic compounds on the surface of Mars. Complex organic compounds do not exist on the moon. They don't exist. They exist on Mars, but not on the moon. Again, it doesn't guarantee life, but the probability just went up. Because of Spirit and Opportunity, we know now that Mars used to have an ocean. In fact, 2/3 of its northern hemisphere was covered in an ocean. We know that because it had an ocean, it must have had a magnetosphere that protected the ocean, and it had, therefore, an atmosphere. So all of these things collude to say that 3 billion years ago, Mars was habitable. Again, I'm not saying it was inhabited, but it had the opportunity to host life at some point in its past. Something happened. It lost its magnetosphere. Maybe the core cooled, and when it cooled, it lost the magnetosphere. And when the core cooled, now you've got all of this solar wind that's hitting the planet. And of course, the atmosphere is being dissipated as well as the water. But the water under the surface, this is an important point, going back to the radiation exposure. The water under the surface of Mars is still there. The liquid water is still there because it's been protected from the radiation. What does that mean for us? It means that if we can get under the surface of a planetary body, we can live for long periods of time. All right. Sorry I killed that dead horse.
It also sounds like you took an astronomy class while you were at Rice too, so that was good. We have a question right here.
I love what you, can you hear me?
Yes.
I love what you shared with us. It sounds so exciting. And I love the moon. I love the Earth.
I love the Earth too.
Yeah, and NASA has achieved so much and provided so many benefits for society, and that's wonderful. I love it. My question is, I'm hopeful that we've learned, because I love my Earth,
Yeah.
some of the challenges that we've had with pollution and things like that. So I'm curious, how are we going to keep the integrity of our precious moon
Yes.
while we're there, while following the space directives,
Yep.
ecologically, sustainability? I would just love to hear your thoughts on that.
Yeah.
Thank you for what you do.
Great questions all. So know this. The Earth science budget of NASA right now is the highest it's ever been. It's supported by bipartisan members of Congress, and it's been signed by the President of the United States. The budget request that just got submitted by the President actually has NASA's Earth science budget higher than 5 of the budgets of the previous administration. So this President and your NASA right now, we are very committed to continuing to study as much about the Earth as we can possibly study. When you look at the Earth science budget of NASA and you compare it to other agencies, if you add the European Space Agency and Canada and Japan and Russia all together, their Earth science budgets collectively, which those are all of our partners on the International Space Station, all those budgets collectively are about equal to the United States budget for Earth science. So we are pulling our fair share. We are doing everything we can to understand as much about our planet as possible. We're studying the planet in every part of the electromagnetic spectrum all the time. So all that being said, I recently had the opportunity to go out to the World Ag Expo in Tulare, California. And over the course of a week, there's 100,000 people that go through there. Why does the NASA administrator go to the World Ag Expo in rural California? I'll tell you why. Because as you said, all of the benefits that come from NASA. So we started sensing the Earth for one reason, to understand how the climate is changing. And what we've discovered is that we can take that and we can understand evapotranspiration from plants on the surface of the planet from space. And from there, we can make very specific calculations as to how much to water and when based on the stress of the plant. And not just how much to water and when, but because we're not overwatering, it enables us to actually have the plant do better because the nitrates remain in the soil. And when nitrates are in the soil, the plants do better, and then the water that goes downstream doesn't have to be cleaned up by all of the water treatment so that humans can drink it. So all of this stuff these are all technologies born from the NASA Earth Science Division that are applications that nobody envisioned even 5 years ago that we're now applying in ways to increase. So here's what we're doing. We're increasing crop yields while preserving water by the tune of about 25% in these parts of California where it's desert. And at the same time, we're preserving the nitrates in the soil. What does that mean? That means when we take these capabilities and expand them, we're going to be able to feed more of the world than ever before because of NASA. Remember what our budget is. Our budget is 1/2 of 1% of the federal budget. And yet we're going to be able to increase food supplies for the entire world. And by the way, those technologies are not just unique to the United States. They can be applied all over the world. And they could be commercialized in a way. If a farmer out there wants even better data and more data, there could be a market out there for people to launch satellites commercially and have the farmers buy it because they can increase their crop yields. Anyway, that's a whole other topic. But know this, There's only one planet that we currently know hosts life, and it's Earth, and your NASA is doing everything we can to understand it. We're committed to that. I'm committed to that. That's how we keep NASA apolitical and bipartisan. I committed when I went through the confirmation process. And in fact, I talked to David Alexander about this when I was going through the confirmation process. My commitment is to follow the guidance of the National Academy of Sciences, because that's how we make sure that the Earth Science Division and all the different missions of NASA remain apolitical and bipartisan. So all that's there. Now, when it comes to other planets and the protection thereof, that's something that NASA is very concerned about as well. And we're part of a group called COSPAR, and it's an international consortium of folks that make determinations as to how ultimately can we explore other planets and not damage them. I'll tell you why that's an issue. If we accidentally place a microbe on another planet through one of our missions, we might later discover that that microbe is there and believe that we just found life on another world. That corrupts the science. So we have to be careful. Now, I will tell you that maybe historically we might have gone too far and actually prevented us from actually going to the most valuable places scientifically because we might accidentally leave a microbe. So we're looking at all of these things right now to make sure we have the right balance. But we are following the guidance of the scientific community, and we will make sure as an agency that what we do in space is scientifically valuable, but also enables a commercial, robust commercial marketplace for the future. So it's a balance, and we're constantly working on it.
So the best job title in NASA, I think, the whole of NASA, is the Planetary Protection Officer. It comes with a cape and everything. I mean, it's just... So I think we have a question here, and then I'll get to some of the ones in the middle.
As a NASA contractor, I'd dearly love to build some walking suits for you for the lunar surface. As you know, though, we haven't seen an RFP yet, and it takes many years to certify such a suit. So my question for you is, when the astronauts go out the door, what will they be wearing?
Great question. And remember, I talked about that budget request amendment. It's going to have to include spacesuits. So when we talk about spacesuits, a lot of people don't realize spacesuits are really spaceships. They're spaceships designed specifically for a human, and they have to be tailored specific to the human, but also specific to the mission. None of that is cheap, and it's very difficult to do. And if you look back and you go back to the 1960s, 1970s, you can see how bulky and challenged. There's a lot of new materials these days. There's a lot of new technologies and capabilities. But ultimately, we need to start working on spacesuits very soon if we're going to achieve, when we achieve, the 2024 landing. It's a great question.
Thank you for coming here tonight. I think you've enthused a lot of us. Of all the things that have been listed tonight, and there are many others, I'm going to ask you to look in your crystal ball. We talked about human protection from radiation. We're talking about in situ development, which is going to, theoretically, you're not going to be down at the poles, so you're going to have robotic harvesting of the water if you're going to make it sustainable for the long run. You've got an awful lot of politics and money to overcome, along with the technical problems in a very short period of time. With all of those things, even assuming our new commercial partners have a new way of doing business and will assume some of that risk and things will be better than they have been when NASA was pulling the cart alone, in your mind, what's the top 2 or 3 long poles in the tent to make all of this happen in the 5 years? Because there's a lot of obstacles. What do you think are the most difficult to overcome?
It's a great question. To clarify some of what you just mentioned, the 2 phases, we talk about the next 5 years, get humans to the surface of the moon as soon as possible. That's our number 1 goal there. Then by 2028, we want sustainability built into the architecture. We want landers to be reusable. We want tugs to be reusable. When I say tugs, transfer vehicles from a halo orbit down to low lunar orbit. We want all of that to be reusable. In fact, most of it's going to be reusable in 2024, but any components that are not need to be reusable by 2028. When we talk about using the resources of the moon, we talk about using that water for life support. That's another challenge. We might not, and I'm not saying we will or won't, but that might not be an objective for 2024. That's a great, I got so much to say about this. But maybe by 2028 and maybe even beyond that. So I don't know about the timeline on that. But I think right now the number one biggest challenge to accomplishing this end state that we need to achieve is the political risk. We have to make sure that this is an American agenda, that this is an all-of-the-above approach, that this doesn't end up as a parochial thing with, southern states against northern states or western states against eastern states. We got to make sure that it doesn't end up in a partisan fight, which NASA has always been apolitical and bipartisan. So I think it can be achieved, but getting the resources is the first step of the process. And there's only one place to get those resources, and it comes from the U.S. Congress, a body that I used to be in. And I can tell you there's no shortage of disagreements on how to do things. You might have noticed. So I think that's the biggest risk and the biggest challenge that I have to overcome. I'll worry. We got to worry about this other stuff as well, but that's my biggest hurdle at this point. To retire some of the technical risk, going back to your other point, one of the first initiatives I had as the NASA administrator is what we call Commercial Lunar Payload Services. We call it CLPS, Commercial Lunar Payload Services. What the CLPS mission is, we said, we identified 9 private companies that we believed had an opportunity to deliver NASA payloads to the surface of the moon as early as within a year. 9 companies that could deliver a small payload, I'm talking about 10, 15 pounds, to the surface of the moon within a year. And we want to do that for scientific purposes. I mean, there's some people in the room that might have been involved in helping us come up with this idea. Now, at the end of the day, when we go to the moon with these small payloads, we were focused on a whole host of different scientific endeavors. Now what we need to do is we need to say, what are the most valuable places on the moon where we need to go right now so that when we send humans, they're actually going to be productive when they're there. So we talk about the South Pole of the moon, the value of the South Pole, again, hundreds of millions of tons of water ice, but there's also what we call peaks of eternal light. I know I'm talking to a space crowd, so I'm just speaking to the choir here, but there might be people watching online. These peaks of eternal light are places where there's almost permanent sunlight at the South Pole of the moon, and you've got these permanent shadows where the water ice would be. And those are the most valuable places. And we need to figure out, are there places on the moon where there's pure water ice? I don't know. Neither does anybody else. We didn't know that about Mars until we actually sent the Phoenix lander to Mars. Phoenix lander grabbed a piece of the dirt, and it was pure water ice. Pure water ice. There was no dirt or iron or anything mixed in, pure water ice. Does that exist on the moon? I don't know. Maybe some people in the room know. I don't know. But then the question is, if it's not pure, then how do we take it out, and then how do we use it for what we need to use it for? So these are all things that we're going to start working on with the CLPS missions very, very soon.
Hello.
Okay, I've been told 2 more questions.
Okay. Yeah, well, this is probably more related to the budget, and it's an idea, and I want to hear your opinion. We have the most developed capital market here in the U.S., okay? And I'm a geophysicist turned investment banker, and you have seen that we have invested in countries that maybe we never get a return back, like for gold, oil. Actually, Saudi Aramco raised $12 billion last week, and 30 years bonds. So hearing you talk about that you have to ask the Congress for budget, why don't we go to the capital markets? I heard yesterday, for example, that the lowered market is $62 billion.
Right.
And then that a ton of H3 that is on the moon, it's probably worth $1 billion if you bring that here and create fusion energy. So why NASA is not thinking on going into the capital markets to raise the amount of money that we need for space exploration?
Wonderful question. The answer is we are thinking that way. So when you think about the commercial lunar payload services that I talked about, those are companies, a lot of them are small companies raising millions of dollars on their own, making their own investments. Then all NASA does is we say, we have this particular instrument that we want delivered to this particular location. We're not going to purchase, own, and operate the hardware. We just want to buy your service. We want to be the customer, not the tenant. And so that's what we're doing. And so when we put out a CLPS contract and we identify 9 companies and we say we believe these companies have the ability to take us to the moon and we want to be a customer, then what happens is those companies, they're able to go out and privately raise money on their own to ultimately help us accomplish that end state. So the answer is yes, we're thinking that way. Commercial resupply to the International Space Station is leveraging off-the-shelf rockets. Oh, you're talking about, okay, he's saying NASA itself can go raise bonds. So you're talking about like, yeah. So you're talking about like war bonds kind of a thing. Okay. So I'm all for people raising money to go to the moon and do all these other activities. I don't know that NASA needs to be creating the capital markets for that. We want to be a customer. In my view, we don't need to go raise money by selling bonds and then using the proceeds from our missions to pay off the bonds. To me, that is what capital markets are for, and not the government. But I can tell you that your government sells bonds all the time. We're not in war. We're just in debt. And yeah. And so it's not a concept that's unfamiliar to those of us in Washington, D.C.
And before we go to our last question, I mean, this is happening. It's happening with Earth remote sensing data using current resources, either NASA or commercial, new resources that are going up, because they're selling that product. And once the value of a lunar gateway or these other locations come into play, the commercial markets are going to pick up and raise the capital to make that, because they see a return on investment. Right now, I believe, if you can correct me if I'm wrong, Jim, is that NASA sees itself in part as an anchor tenant to help this get established, which I think is a very important role that they have. And then the markets will speak for themselves. If you can make money by mining platinum off an asteroid, it will happen. Yeah, and but NASA is the space agency. NASA does these great things. They lay the path, and then all these industries shall follow. And I think that's an important role because of the non-partisan, the doing it for the country, not for the profit side of things. I think NASA has to have that aspect. So I'm sorry, that was my own little tiny soapbox.
No,
you're exactly right. I'm afraid we have one last question coming back from here, and then we'll finish up.
Hi, I'm Greer. I work out at the Johnson Space Center. Just want to say thank you for being here, and I can share this with my family, so it's really cool.
Oh, that's awesome. Thank you for being here.
Thanks. I'm really excited about the acceleration of getting to the moon in 5 years, but if we want to do this with international partners, how are we able to pull them along with that, either directly being there step by step with us, or not precluding them from designs or allowing them to join later?
A wonderful question. A couple of things to note. Number one, when we accelerate our path to the moon, we have in that path the Orion crew capsule with the European service module. So if we need more SLS launches with Orion and the European service module, we're going to need more out of the European Space Agency, and the preponderance of that comes from just a few countries in Europe. And so my goal is to convince them to be with us with the 2024 effort. And I intend, in order to make that happen, I will be making trips to Europe, not just to meet with the heads of agency, but to meet with the heads of agency and their ministers of their governments, whether it's the ministers of science or the ministers of finance, or however high they'd like me to go to explain to them what we're trying to achieve and how important they are to that end state that is important for the entire world. So that's the starting point. It's also important to remember that 2024, we have a directive from the president that the vice president delivered at the National Space Council that the first woman and the next man on the moon will be Americans. So when we talk about that lander in 2024, guess what? If we're bringing a preponderance of the assets to the effort, then we're going to be putting our crew on there. But that crew could be on a lander that has 4 seats. Or it could be multiple crews. It could have a 2-seat lander and another 2-seat lander. And we could have international partners on that lander depending on what they want to contribute to the effort. The bigger the effort, the bigger the reward. And so all of this is part of a kind of a grand bargain that we're going to need to put together. It's also important to note that the architecture that we're building is open. So we talk about the launch vehicles, the tugs, the reusable command module. We talk about the landers themselves, the way we do docking, the way we do data, the way we do communications, the way we do life support. Everything is going to be open and available to the public. You can go online and read about it. And if you want to build your own lander and dock it to the reusable command module, the gateway, and take your own lander to the surface of the moon, we want that. So maybe Japan wants to have a lander. I don't know if they do or not, but certainly I'm going to talk to them about it. Maybe another country wants to have a lander. They can use the standards that we're creating and join the effort and have their own folks, maybe their own robots, maybe their own landers on the moon using our architecture that we're making open to the public so that everybody can participate. And we want all of those standards to be open even in 2024 for the first, quickest moon landing. So just because the first man and the next, I should say the first woman and the next man on the moon are Americans doesn't mean that international can't participate. We want them to participate. And if the lander is a 4-seater, guess what? We could put more people there at the same time. So I think it's important. Open architecture, critically important. The other thing is sustainability. We need international partners for that sustainable piece. We need other modules on the gateway. We need, and by the way, what we're working on now is we're trying to create the synergies, and there's people in this room that are working on it, synergies between the Science Mission Directorate and the Human Exploration and Operations Mission Directorate. So on that gateway, that reusable command module in orbit around the moon, we're going to be able to do lunar surface science, we're going to be able to do space science, and we're going to be able to do astrophysics from that gateway. So bringing all those elements, because remember, when you're on the far side of the moon, it's very quiet from an electromagnetic spectrum perspective. So there's plenty of opportunities to do all kinds of science from the gateway, plenty of opportunities to get humans to the surface of the moon to do even more science from the moon even out into deep space with maybe very low frequency kind of antennas. Think about wire antennas on the far side of the moon where it's very quiet, looking all the way back to the first light in the universe, if you can even imagine that. So there's lots of opportunities here to include international partners. The architecture is open. We need them. We want them. I'm going to be traveling the world to convince them to join us in this effort. And I'll tell you right now, 2 things. When I was in Colorado, I met with the heads of agencies from over 21 countries. And number one, they're very concerned because they want to be a part of it. I think that's important. They're concerned that we might go alone. They all want to be a part of it. That's important. They want to do it. So that's a good thing for us. The other good thing for us is that they're all super excited. And look, we've been to the moon. We're the only country that's ever been to the moon. They want to go to the moon too. Everybody wants to have their own flags on the surface of the moon, and we want to enable that. That's American leadership. It's who we are, it's who we've always been, and it's who we're going to be tomorrow. So, David, thank you so much for having me. Thank you.
So I think it's true that NASA's always been an agency with great ambitions, and for the most part they've achieved those ambitions. And it's really great to hear that that continues today. And all the people from NASA in the audience, I know many of you, thank you for everything that you do. It's a great, even just to watch through the window and see what you do is fantastic. And thank you again, Jim, for a great insight into what's going on and all the ambitions to come forward. So please join me again in thanking. And you know my Blues Brothers tagline, you don't have to go home, but you can't stay here. Thank you, enjoy your summer, and we'll see you in the fall.